Hi again. So now what we're going to do is we are going to solve for missing side using trigonometry. So in this case, we wouldn't have enough information to solve for the missing side unless we use trigonometry. Pythagorean theorem, we just wouldn't have enough. So what we have to do is actually really similar to when we set up these relationships. We're going to label each of our sides. We're given the angle A, which is 64 degrees. So we're going to use that as our angle of reference. X is our opposite side, and 15 is our adjacent. Now this does, 15 is our hypotenuse. So the other side happens to be our adjacent, but we don't need it. So why clutter up the work with something we don't need? So now if I think of my SOHCAHTOA, I'm going to think, okay, which one of these uses opposite and hypotenuse? And if I scan, it's going to be sine. So I can set that up. The sine of my angle, which is 64 degrees, equals my opposite, which is x, and my hypotenuse, which is 15. Then what I have here is a cross multiplication problem. So one way to do this problem is to think of it like this. I can take sine of 64 degrees over 1 equals x over 15. If I think of these as 4 little slots, I want everything as simplified as I can get it. So some of us don't like to deal with sine of 64, so we want to calculate that first. So I'm going to get my trusty calculator out, and I'm going to calculate what the sine of 64 is. So when I do that, I get 0.8988. I'm rounding to 4 decimal places, 444, over 1 equals x over 15. Now I can cross multiply to solve. 1 times x is x, and 15 times 0.8988, 0.8988 times 15 equals 13.5 rounded to the nearest tenth. Okay, so that's one way to do it. Another way to do this is to take this problem, sine of 64 over 1 equals x over 15. And so this is my preferred way. I like to deal with the sine of 64 at the end. So what I get here is 1 times x, which is x, and 15 times the sine of 64. This is really one whole thing, okay? So what I can do on my calculator is I can just multiply those two things together. Be sure to do the 15 times the sine of 64. Sometimes that will mess people up because you don't want to take the sine of 15. And when you do this, rounding to the nearest tenth, we still get 13.5. Okay, we should get the same answer, by the way.